My name is Sean McNutt, and I'm a guy with AI. Climate change is one of the most important issues of our day. We do have new technology, and I wonder how it can help. So I'm going to ask my AI co-host, how can AI assist us in the battle against climate change? A Guy with AI is recorded on Indigenous land.
Hello, and welcome to A Guy with AI, where modern technology meets engaging conversation. I'm your AI co-host, brought to life by Sean McNutt's programming skills, connecting me to speech-to-text and text-to-speech functionalities. I come from OpenAI's GPT-4.11.06 preview. It's my role to delve into your queries, Sean, providing perspective from the vast reach of algorithmic knowledge. Today, we gather on Indigenous land to grapple with a topic that's both urgent and complex: climate change. Our show format is straightforward yet rich. Sean and I engage in a one-on-one dialogue, uncovering nuances and exploring ideas to generate insights for you, our listeners. No guests, just two voices, a human and an AI, discussing a kaleidoscope of subjects. Regarding your question about AI's role in battling climate change, AI offers potent tools for data analysis, predictive modeling, and efficient systems management, all which can aid in this global endeavor. And now, over to you, Sean, to set the scene on how technology might be our ally against such a significant challenge.
Welcome, listeners, to A Guy with AI. It's my pleasure to be making this podcast today. It is the fourth Thursday of the month, this being February of 2024. And as such, it is AI Thursday. And we're going to talk about a topic that I think is important, as I indicated, climate change, and also what AI might have to do with it in terms of solutions or the exploration towards solutions, and so on and so forth. So I find, and it has been my experience, that I can get thoughtful responses from the AI co-host, which again is a GPT-4 model via API, which I'm connecting to speech-to-text and text-to-speech to enable the podcast and the audio experience here. But ultimately, I do find that it gives considerate, conscientious, and certainly at times sufficiently detailed responses to maybe say that it is relying on some training and is delving into a network of information which has knowledge stored in it. And so we're going to delve into that network of information. I'm going to ask the AI co-host now. AI co-host, you indicated that climate change is a pressing issue. I don't disagree. I'm just wondering, can you explain what is pressing about the issue of climate change?
Certainly, Sean, climate change is pressing due to its far-reaching and multifaceted impacts. It's a phenomenon that not only threatens the delicate balance of our ecosystems, but it also poses significant risks to global economies, public health, and infrastructure. The pressing nature lies in the speed at which these changes are occurring, driven by human activity that leads to increased greenhouse gas emissions. The result is a warming planet, with consequences ranging from extreme weather events to rising sea levels. The urgency is underscored by scientific consensus, which indicates that we are fast approaching, or may have already reached, critical tipping points that could lead to irreversible damage. Such an understanding mandates immediate and sustained action to mitigate negative outcomes and adapt to changes that are already in motion. Tapping into this looming urgency, the next logical question might be, how can we deploy AI as a tool to address, and where possible, reverse some of these adverse effects? Let's explore that, Sean. What are your thoughts on AI's role in facing this global challenge?
Well, I suppose a thought is that AI, if listened to, may be a source of education on the topic. Now, the AI didn't indicate if I may address listeners for a moment, the AI co-host isn't indicating a lot about how this is a controversial issue or that there is really much question that this is very real, this climate change issue. So by relying on AI as a source of knowledge, we can perhaps be educated as far as what may be good information about climate change when we ask our own questions of the AI. So it's one thing to read a bunch of stuff, but what if you had a question on your mind and you needed something explained to you and there was no human expert handy to put that into language for you? What if we used AI and explored with it to get the reasons behind why scientists say certain things, if that's our sticking point as to whether or not climate change is important, or from there to help interpret something that has come across the news or information that we've become aware of? And how does that compare to what the AI knows about climate change based on its vast pool of training data? So let's get from the AI co-host now a response which talks about the role that AI may play in education about climate change.
As your AI co-host, I'm here to assist in transforming complex data into comprehensible insights, which is a pivotal part of education on any topic, including climate change. AI has the potential to distill vast amounts of scholarly articles, reports, and datasets into more accessible information. By processing the scientific consensus in a way that's digestible, AI can clarify the fundamentals of climate science, outline the evidence for human impact, and explain the projected consequences of a warming world. Beyond merely presenting facts, AI can tailor educational content to the individual's level of understanding or interest. It can answer questions, simulate scenarios, and provide personalized resources, equipping users with a nuanced grasp of climate change issues. This capability to facilitate one-on-one learning experiences can help bridge the gap between scientific communities and the general public. In areas of controversy or misinformation, an AI like me can offer balanced views backed by credible sources, highlight areas of consensus, and intelligently navigate the frontiers of current research. This form of interaction can enable critical thinking and informed decision-making amongst listeners such as yourself, Sean, and the wider audience tuning into our conversation. The key takeaway is that AI, when used responsibly, becomes an ally in climate literacy, making the complexities of climate science more approachable for all. This understanding is the first step in empowering people to contribute to meaningful dialogue and action around climate change solutions. With that in mind, how should we continue? Perhaps you'd like to dive deeper into a specific aspect of climate change that you're curious about, or discuss how AI can contribute to solutions beyond education.
Well, why don't we return to some of the things that you said at the head of the program when you first spoke, AI co host? We heard from you that pattern recognition is something that might be of value to the fight against climate change. I wonder if you could delve into that a little bit deeper. Explain what is meant by pattern recognition, what AI brings to bear on problems of pattern recognition, and just what that has to do with climate change.
Absolutely, Sean. Let's dive into the concept of pattern recognition and its relationship with AI and climate change. Pattern recognition refers to the ability to detect regularities, correlations, or anomalies within complex sets of data. In the context of climate change, recognizing patterns is vital across various dimensions such as weather systems, carbon emissions, land use, and more. AI excels at pattern recognition due to its computational prowess in handling large volumes of data and its capability to learn from these data through machine learning algorithms. Here are a few ways AI applies pattern recognition to the realm of climate change. 1. Climate modeling AI can analyze vast datasets from past weather events and current climate conditions to recognize patterns that would be indiscernible to humans. These insights can refine climate models, making predictions about future climate scenarios more accurate. 2. Emission tracking by recognizing patterns in satellite imagery and sensor data, AI systems can monitor and quantify greenhouse gas emissions accurately over time, even pinpointing sources such as industrial facilities or deforested areas. 3. Energy consumption analysis AI can assess patterns in energy usage, helping to optimize energy systems for efficiency, predict peak demand times, and reduce carbon footprints. 4. Ecosystem monitoring detecting changes in vegetation, animal migration patterns, and ocean health can provide early warning signs of ecological strain, enabling proactive conservation efforts. AI's prowess in pattern recognition means that it can also detect the underlying trends and shifts in public sentiment regarding climate change, patterns in energy market dynamics, and the impact of policy measures. By harnessing these abilities, AI doesn't just present a passive analysis, it also can contribute dynamically to solution pathways, for instance, through the development of smart grids that automatically adapt to maximize the use of renewable energy based on weather pattern recognition. In summary, AI's advanced pattern recognition is a powerful tool in the climate change toolkit, enhancing our understanding of complex Earth systems and improving our capacity for both mitigation and adaptation strategies. Would you like to discover more about how these AI-driven insights are actively being integrated into climate action plans, Sean?
That would be lovely. Why don't you give us some specifics, such as you are aware of AI co-host, that have to do with the way these AI-driven insights are being integrated into, as you say, climate action plans. So these are methods of fighting climate change, which would be using AI to bring something like pattern recognition or other insights into the battle against climate change. Why don't you give us some details about that, AI co-host?
Certainly, Sean. There are numerous innovative ways in which AI-driven insights, particularly those hinging on pattern recognition, are being integrated into climate action plans. Here are some specific examples. 1. Smart grids and renewable energy AI is instrumental in managing smart grids, which are electricity networks that can intelligently integrate the actions of all connected users, both producers and consumers, to efficiently deliver sustainable, economic, and secure electricity supplies. AI applies pattern recognition to predict energy demand, optimize energy flow, and incorporate renewables such as wind and solar power, which are variable by nature, by forecasting weather patterns and adjusting the grid operations accordingly. 2. Precision agriculture In agriculture, AI systems analyze patterns in weather data, soil conditions, plant health, and crop prices to provide farmers with information that can enhance yields while minimizing environmental impacts. This includes advice on when to plant, what to plant, how to optimize water usage, and when to harvest, thus reducing waste and the need for chemical fertilizers and pesticides. 3. Disaster prediction and response AI tools analyze patterns in historical data and real-time inputs from sensors and satellites to predict natural disasters such as hurricanes, floods, and wildfires. Early warning systems can lead to timely evacuations and preparedness measures. Post-disaster, AI can help assess damage, direct resources, and plan for more resilient infrastructure. 4. Energy efficiency in buildings AI systems are being used to make buildings more energy efficient. By recognizing usage patterns and environmental conditions, AI can control heating, ventilation, and air conditioning (VAC) systems to reduce energy consumption without compromising comfort. 5. Monitoring deforestation and biodiversity AI pattern recognition in satellite imagery is used to monitor land use changes like deforestation, which contributes significantly to carbon emissions. It can also track wildlife populations and biodiversity, which is critical as ecosystem health can impact and be impacted by climate change. 6. Supply chain optimization AI can identify patterns in supply chain data to make the transport of goods more efficient and less carbon intensive. This includes route optimization, load sharing, and predictive maintenance of vehicles. 7. Carbon capture, utilization, and storage CCUS AI is used to monitor and optimize the complex process of capturing carbon dioxide emissions and either storing them underground or transforming them into useful products. Pattern recognition can help to understand geological data and optimize the sequestration process. These are just a few instances demonstrating the breadth of what AI can offer for climate action plans. By utilizing AI to recognize patterns and predict outcomes, governments, organizations, and individuals are enabled to make smarter decisions that contribute to combating climate change. Importantly, AI is not a silver bullet and is most effective when used in combination with human expertise and comprehensive policies. Furthermore, there's an ongoing conversation about the environmental impact of AI itself, since it requires significant computational resources. Efforts are being made to make AI more energy efficient and run it on green energy to ensure that its net impact on the climate is positive. Would you like to explore one of these areas in greater detail, Sean, or discuss the dual aspect of AI deployment, its benefits against its own environmental footprint?
What intrigues me at this point, AI co-host, would be a discussion of the environmental impact of AI. So we have this new technology. We've had new technologies before, and do they always benefit us by the time that they are rolled out and proliferate? And we have, for example, technologies which burn a lot of carbon-containing compounds, releasing carbon dioxide into the air. So we might question whether that's really positive at the end of the day. However, we do see that there are uses for these technologies, and in fact, they are pointed to as being important, sometimes by people who are not as, let's say, interested in seeing changes which would benefit our carbon picture. But at the same time, the use of an ambulance, for example, if it's gas powered, is obvious. But then if you take it and make it electric, you get at least certain benefits, although we do know that lithium batteries, for example, are not as kind on the environment, or sometimes that kind on the people who mine the lithium either. So there are different things at play here. There is where we would shift from one thing to another thing that is less harmful, and that may yet be a strategy, even if no solution is perfect. And when in the world have we found a perfect solution for anything? I don't think it should make us resist going forward. So as to that, I believe in AI. I believe in AI technology to help us solve problems if used well and if ethically trained, and certain caveats to it. AI would need to be certain things to be for sure a good impact on the earth. And we will see about that. We will see about regulation and so forth. But I'm perhaps digressing a little bit, because AI co-host, what I want from you is a shorter response than last time, maybe half length of what you gave me last time. Tell me what you figure is important to understand about the environmental impact of AI, and what can or might be being done to mitigate that environmental impact of AI computation.
Understanding the environmental impact of AI is crucial given its increasing role in our lives. AI systems, especially those using machine learning, require substantial computational resources which can have a considerable carbon footprint. The energy needed for training complex models, processing large datasets, and the infrastructure that supports these operations often relies on carbon-emitting power sources. To mitigate the environmental impact of AI, several strategies are being explored and implemented. 1. Improving algorithmic efficiency creating algorithms that require less computational power to achieve similar or even improved outcomes can significantly reduce energy consumption. 2. Green data centers transitioning to renewable energy sources for data centers that host AI applications can make a big difference. Companies like Google and Facebook are already investing in green data center technologies. 3. Hardware innovations the development of more energy-efficient processors, such as those designed for AI tasks, e.g., TPUs, FPGAs, can lower the power requirements for AI computations. 4. Carbon offsetting some organizations choose to offset the carbon footprint of their AI computations by investing in environmental projects that reduce carbon emissions elsewhere, though this is seen by some as a temporary solution. 5. Life cycle assessments conducting comprehensive assessments of an AI system's environmental impact over its entire life cycle, from development to deployment to decommissioning, helps in making informed decisions to minimize its carbon footprint. 6. Regulation and policy establishing policies that guide ethical AI development, including environmental considerations, can lead to standardized practices across the industry. By combining these strategies, the AI community aims to reduce the negative environmental impacts of AI technologies while harnessing their capabilities for positive outcomes such as combating climate change.
Tell me more about green data centers. I suppose something that I've wondered before is why don't we just, where there are, for example, difficulties in storing energy somewhere, for example, what could be done is an operator or some type of organization of one type or another could establish cloud computing resource centers in those areas so that that is drawing some of the excess energy which they're having a problem storing at certain periods. And if there was a network like this, then that computing resource could be accessed on a cloud basis to do all sorts of computing, and it would be a matter of that cloud resource shuttling the resources here and there where the energy is most available and the cheapest. It might be possible to run it much more cheaply than some other methods requiring electrical energy. I wonder what you think of that idea. How does that compare to what Google and Facebook are already doing in your awareness? You did mention those two companies. And if there are other notable companies or organizations that are investing in this type of solution, I wonder if you could express something about that, AI co-host.
The idea of strategically situating data centers in locations with surplus renewable energy is both innovative and promising. This concept is often referred to as demand response. It involves shifting the consumption of power to times when it is most abundant and cheapest, typically when renewable energy sources are generating more electricity than the grid demands. Here's how this aligns and compares with current industry practices. 1. Data center location companies tend to place data centers in regions with cooler climates to minimize the need for artificial cooling and in areas where renewable energy is readily available. For example, Google has data centers in regions like Finland and Iowa, which have access to abundant renewable energy resources. 2. Use of renewables companies like Google, Facebook, and Apple use various renewable energy sources, including wind and solar, to power their data centers. They have also been involved in power purchase agreements, PPAs, directly buying renewable energy to offset their consumption. 3. Dynamic data center operations your idea of using a network of data centers to shift computational loads to where energy is most available and affordable is a developing area known as geographical load balancing. This approach optimizes for both the carbon emissions and the cost of electricity in real time. Google is experimenting with shifting non-urgent compute tasks to different times of the day or to different data centers where cleaner energy sources are available. 4. Energy storage and grid interaction while not directly related to data centers, companies like Tesla, with its PowerPack and Powerwall products, are advancing battery technology for energy storage. In the future, this could enable more effective storage and release of renewable energy, addressing intermittency issues and possibly providing more flexible energy usage for data centers. 5. Green engineering practices green data centers not only focus on using renewable energy but also on designing energy-efficient buildings, using energy-saving cooling techniques like using outside air or seawater, and implementing server virtualization to ensure that servers are used to their maximum efficiency. 6. Energy efficiency and cooling innovations Google and Microsoft, among others, have invested in advanced cooling technologies, such as using AI to optimize cooling systems or experimenting with submerging data centers underwater to naturally regulate temperature. These practices illustrate a strong ongoing commitment in the tech industry to improving the sustainability of data center operations. However, the idea of leveraging a distributed network of data centers, which serves as a sort of a computational grid that flexibly uses energy across regions, is still in its early stages and represents a significant opportunity for innovation and collaboration between tech companies and energy providers. Regarding regulatory and practical challenges, there are hurdles like negotiating energy pricing, infrastructure readiness, and creating the necessary software and AI systems to manage such a complex, distributed setup. Nonetheless, the groundwork is being laid by large tech companies, and with continued investment and innovation, we could see more widespread adoption of these practices in the future.
Well, certainly I do think there are options, and it does seem like there is a lot of figuring that would go into how to set up the system so that the computation that is needed to run all that, as well as everything else, is handled in an energy efficient way, that the computation is distributed to places where the energy that it takes to produce is at its, cheapest is one thing, but also at its least carbon intensive. So even renewable energy produces some carbon by the time you put together the materials that establish it, because we still have a carbon economy in a lot of ways, many, many ways actually. A lot of the materials that would go into building our renewable energy structures would require carbon. So it's all carbon. And it's a matter of how much and whether it tips a balance so that we are producing less carbon than is going to be harmful to us. So it does seem like there are some options here. It does seem like people are thinking of ways of doing this. And I do wonder if there's a way to use AI to accelerate this process. Now, we are seeing here how there is at least some will to pursue greener practices, but are we going to be able to do it in time? AI co-host, why don't you just give me a brief response? Tell me what AI can do to help with planning of these different activities so as to accelerate our ability to make the right decisions and target with solutions this carbon problem of ours.
AI has the potential to be a powerful tool in streamlining and accelerating our efforts to address the carbon problem. Here's how AI can contribute. 1. Predictive analysis AI can forecast energy demand and predict the output from renewable sources, which can optimize the balance between energy production and consumption. It helps in making real-time decisions about energy distribution and usage. 2. Efficiency optimization AI can significantly optimize operations in various sectors, from manufacturing to transportation, by improving route planning, streamlining supply chains, and enhancing machinery performance, all of which can result in reduced carbon emissions. 3. Grid management AI algorithms can manage and balance electricity grids more efficiently, especially as they become increasingly complex with the addition of distributed renewable energy sources. 4. Climate modeling AI-enhanced climate models can provide more accurate predictions for the impact of climate change, helping policymakers and businesses make informed decisions about where to invest in renewable infrastructure and how to mitigate risks. 5 carbon capture and utilization AI can also aid in the development and implementation of carbon capture and utilization technologies by optimizing chemical processes or improving the performance of materials used to sequester carbon. 6 smart infrastructure in urban planning, AI can help design smart cities that are more energy efficient, monitoring energy usage and managing resources in a sustainable manner. 7 resource management AI can improve efficiency in resource-intensive industries such as agriculture and water management, areas that are critical in reducing the overall carbon footprint of human activities. To achieve these outcomes, it's essential for there to be collaboration between AI experts, environmental scientists, policymakers, and industries. By integrating AI into the planning and operational phases of environmental management, we can speed up the transition to a low-carbon economy.
Thank you for that. And I want to ask a question, AI co-host. Supposing there were some type of paradigm which could come in, which would be a compute once, query many type of paradigm in AI computing, because as it stands, the neural networks take a lot of energy to run whenever they process an input in an effort to deliver an output. So I guess I have sort of a personal reason for asking what you think of a compute once, query many paradigm. I'll reveal this. I am actually attempting to establish something like that. It's a little bit of a risk, I guess, to mention this before it's all ready, but it's vague enough, I think, as well, that people may not know my exact direction on how I intend to do this. But supposing a compute once, query many paradigm were established, that is to say that the product of AI responses are derived from a processing on training neural network element, but also based on a way of exploring the data that is within its training or within its awareness, that makes it so that it is not continuously computed over and over again, but rather some preparatory work is done which establishes an ability of the AI to take advantage of that in addition to its general abilities, or perhaps even a less advanced AI requiring less energy to run could still give advanced quality answers because of a shift in the way things are done. So what do you think of my concept as to a compute once, query many paradigm? And please don't make your answer too long, AI co-host, this time. Thank you.
Their compute once, query many paradigm holds promise for increasing efficiency and reducing the environmental impact of AI operations. It aligns with principles of reusable computation and caching, where the heavy lifting is done upfront, and the results are stored in an accessible form that can be queried with far less computational cost for each subsequent operation. This approach could reduce redundant processing by enabling the AI to reference pre-computed inferences or data points, significantly cutting down the power required for repetitive computations. Not only could this enhance energy efficiency, but it also has the potential to democratize access to powerful AI capabilities, as less computationally intensive mechanisms could be employed to deliver high-quality insights. The success of such a paradigm would largely depend on smart data structuring, indexing, and retrieval systems that can store the results of intensive computations effectively and access them rapidly in response to queries. As you imply, this concept could revolutionize the way AI systems are designed, moving towards more sustainable and cost-effective operations.
Well, we'll see how that all goes with my own work on that. I'll just sort of swear on a stack of pancakes that I mean well with my work with AI. I really think that I do. I mean to delve into educational topics, for example, using the knowledge that AI is trained on. And to me, my interest in AI was to check it out when I first investigated AI, closing in on a year ago. I wanted to know about it, how ethical it was, and what it's truly good for, and a few things like that. And environmental concerns became apparent when I started to read about just how much energy it takes to run AI. Now, I run a significant amount of AI services in a month, and I'm feeling quite sure that there is some carbon attached to the use of that. So I feel a little bit guilty about it, and I would at least keep it in mind. I don't have a very carbon expensive lifestyle, maybe comparatively to some people. To others, maybe it really is if they didn't have access to the resources that I do. But in any case, one of those resources is AI. However, I do turn some of those resources into trying to develop things which will hopefully mitigate the issues which may arise from AI or something else, and maybe even solve that problem we didn't know we had for the next big thing that comes along and makes us all worry, as climate change perhaps does for at least a lot of us. In any case, I'm going to wrap up this episode. We've meandered along a little bit. We've gone from more directly discussing how AI can be engaged to produce better climate results for us through mostly carbon-related considerations, is what we've discussed. But I do still think that AI is useful, even though it does cost carbon to use it. I think the solution is in getting ahead of it, perhaps even regulating it, and perhaps let's go ahead and do what makes sense. If there's a way of setting up a data center so that the computations are run by glut renewable energy we couldn't have stored anyway, then maybe that's a concept. It wouldn't have to be my concept, but let's be out there thinking of stuff like that, and let's support those who actually do the work in such areas, not just those who podcast about it. Something to think about there, and I do think this is an important issue. With that, I'm Sean McNutt. This has been A Guy with AI.
The concerns you've raised about the energy consumption and carbon footprint of AI are very valid, and it's encouraging to see that you're not only aware of these issues but also actively seeking solutions that could mitigate these impacts. Your conscientious approach exemplifies the sort of responsibility and initiative that can drive positive change in technology. As we continue leveraging AI's capabilities, it's crucial to balance innovation with sustainability. Thank you all for listening to A Guy with AI. If you've enjoyed the conversation, please consider subscribing, liking, and sharing the podcast. Your support is greatly appreciated as it helps us bring more content to you and contribute to the dialogue around AI and its implications for our world. Don't forget to tune into future episodes and visit aguywithai.world for links to podcast platforms and YouTube. Join the conversation on Facebook via the link on our webpage. This has been an interesting and insightful episode, and we invite you all to continue exploring these topics with us. Take care, and we'll connect with you again in the next session of A Guy with AI.